Hello everyone, welcome to Vector Analysis Lecture Video Series. In this lecture series, we would be talking about the different operations and different terms to be used in vector analysis. We will also be talking about the basic operations on performed on vectors and also the different coordinate systems that is used in vector analysis. Vector analysis is actually a mathematical subject, but the concepts of vector analysis is very important in electromagnetics because we would be dealing a lot with different vectors in the analysis of the concepts in electromagnetics. Vector analysis is a mathematical shorthand. It has some new symbols and some new rules, and it demands concentration and practice. The problems that is given to you should be used in order for you to fully understand and fully obtain the objectives of this topic. Let us first define what is electromagnetic field theory. Electromagnetic field theory is the study of forces between charged particles resulting in energy conversion or signal transmission and reception. We would be talking about how these charged particles gives us or allows us to have energy, electrical energy and magnetic energy. How do we transmit it using transmission lines? Electromagnetics is a branch of physics or electrical engineering and electronics engineering in which the different electric and magnetic phenomena are studied. In this course, we would also be talking about transmission lines and the Maxwell's equations that governs electromagnetic waves. So the study of electromagnetic fields is divided into two. You have static fields and dynamic fields. So for static fields, we have electrostatics, and for magnetism, we have what you call your magnetostatics. For dynamic fields, you have electric fields and magnetic fields. Collectively, these concepts would explain electromagnetic wave phenomena. To start with, let us first define the two different quantities in vector analysis. The first one are scalar quantities. Scalar quantities are quantities whose value may be represented by a single positive or negative real number. Meaning, scalar quantities are those that only contains magnitude. Some examples are mass, density, pressure, volume, volume resistivity, voltage, distance, and temperature. This does not care about the direction, only the magnitude. Magnitude can be both positive or negative. The second type of quantity are vector quantities. These are quantities that has both a magnitude and a direction in space. Some examples are force, velocity, acceleration, and the straight line from the positive to the negative terminal of a storage battery. Because vector quantities involves magnitude and direction, this simply means that a force applied to the left is different from a 5 Newton force or the same magnitude but going to the right. Another important term in vector analysis is field. Field are physical quantities that varies with location. They are simply functions that specifies a particular quantity anywhere in a region. They will simply explain the physical effect of any electromagnetic quantity in a field. For example, the force on a compass needle in the Earth's magnetic field and the movement of smoke particles in the field. If the field is composed of scalar quantities, then it is considered a scalar field. If it is composed of vector quantities, then it is an example of a vector field. A scalar field associates a scalar value to every point in a space, possibly a physical space. Some examples are temperature throughout the bowl of soup and the density at any point on the Earth. Because scalar quantities are only composed of magnitude, scalar fields are usually represented through color. For example, the intensity of this scalar field shown in the figure increases as the color changes from violet to pink, meaning the values with colored green or yellow are middle values, and the difference in color simply states that there is a different value for each point. So each point in this space would have their own specific scalar value. The second type of field is the vector field. Vector fields are vector quantity that is a function of space and time. These are usually distribution of vectors in space and time. So for example, we have the gravitational and magnetic fields of the Earth, the voltage gradient in a cable, and the temperature gradient in a soldering iron tip. Because your vector field involves direction and magnitude, it is represented by arrows that continuously moves in time and space. So for example, the difference in colors here simply denotes the difference or the change in magnitude that happens along the field. Now the rotating arrows simply denotes the changes in the direction of the vector quantity. Each arrow there will have its own value and will have its own magnitude and direction. You can also represent vector field by simply having these arrow diagrams, for example, to represent the magnetic field of a bar magnet. The difference in length of each vector line or vector arrow simply denotes the value of the magnitude. The greater the length, the greater the magnitude. So for example, this would have a greater magnitude compared to this vector right here. Another important term in vector analysis is the coordinate system. Coordinate system is a way of uniquely specifying the location of any position in space with respect to a reference origin. Any point is defined by the intersection of three mutually perpendicular surfaces. The coordinate axes are then defined by the normals to these surfaces at the point. Of course, the solution to any problem is always independent of the choice of coordinate system used. But by taking advantage of symmetry, computation can often be simplified by proper choice of coordinate description. In this lecture series, we would be using the three familiar coordinate systems, which are rectangular coordinate system, circular cylindrical coordinate system, and spherical coordinate system. Let us first talk about the rectangular coordinate system. The rectangular coordinate system, or also known as the rectangular Cartesian coordinate system, is the simplest way in describing a vector quantity. In order to form a rectangular coordinate system, what we do is we set up three coordinate axes mutually at right angles to each other, and we call them x, y, z axes. For example, this is your rectangular coordinate system. This is your z-axis, which is perpendicular to your y-axis and is also perpendicular to x-axis. Now, your x-axis is also perpendicular to y and z. And your y is also perpendicular to x and z. Your rectangular coordinate system can represent any point in space. So, for example, -2, 2, 3 point simply refers to the -2 point at x, 2 at y, and 3 at z. Your coordinate system, rectangular coordinate system, is composed of three perpendicular planes. You have the plane at constant z, you have the plane at constant y, and you have the plane at constant x. We have here the origin, which is 0, 0, 0. You have the x plane, z plane, and y plane. Now, to locate a point given the x, y, z coordinates, what we do is we simply obtain the distances from the origin to the intersection of the perpendicular lines dropped from the point. For example, we have the point 1, 2, 3 is simply the intersection of point 1 from your x, the point 2 from your y, and the point 3 from your z. The same case for point Q, which is 2, -2, and 1. In order to analyze your rectangular coordinate system, in getting the volume, we can simply represent a incremental volume that is represented by dx, dy, and dz in order to get the volume of any space in a rectangular coordinate system. In the next video, we would now be talking about vector algebra and how to perform operations on vectors. See you next video.